This video is on Unit 8 on trig, Chapter 15 on right triangle trig, lesson number 2, finding side and angle measures. So in this lesson, we are going to use our trigonometric ratios to find the missing sides or missing angle measures in a right triangle. In your examples here, the directions tell you to find the value of x, round to the nearest tenth. So looking at example number 1, you can see where you've got your 64-degree angle, and that's your theta. From that, you have the opposite side, or you're looking for the opposite side, and you have the hypotenuse. So one of the issues that a lot of students will struggle with when using their trig functions is not knowing which one to use. So what I would encourage you to do on each triangle is label your parts. Find your theta, which is your degree, your angle measure, and then label your parts from that angle so that you know which function to use. So if we're looking at opposite and hypotenuse, that's going to be sine. So we're going to use sine theta is opposite over hypotenuse. So sine of 64 equals the opposite is x over the hypotenuse, which is 25. Let me just go ahead and put that 25 in there. Just substituting the numbers that we know into that formula. Now what you want to do is you want to treat this like it is a proportion and use your cross products. So 1 times x is x, and we are going to multiply sine of 64 times 25. So you're going to go to your calculator. You're going to take the sine of 25. Oh, you know what? Let's go to mode. Let's make sure that every calculator is in the degree mode. So we are working with degree measures, so you have to make sure you're in degree mode, which I am. So sine of 25, close your parentheses, and we're going to, actually it's sine 64 times 25. And that's going to give us 22.5. So the length of that leg is 22.5. You're going to do the same thing with every single one of these. Let's jump to number 4. Number 4, you've got a 35-degree angle. Again, there is your theta. You have opposite, and you're looking for adjacent. You do not have the hypotenuse, nor do you want the hypotenuse. So you've got to look at opposite and adjacent, which with those two, it's going to be tangent. So tangent of theta is opposite over adjacent. So filling in our known pieces, tangent of 35 is equal to 9 over x. Now when you do this one, when we do the cross products on this one, what you have here is the tangent of 35 times x is equal to 1 times 9 is 9. And then we're going to divide by the tangent of 35. And I like to wait until I know what I'm going to be dividing before I go to the calculator, just so that you've got a more accurate answer. If you do the tangent of 35 and you round it there, your answer is not going to be as accurate. So now we're going to take 9 and divide by the tangent of 35. So 9 divided by the tangent of 35 is going to give me 12.9. Let's do one more. Let's do number 6. Number 6, we've got our theta, which is 30 degrees. So we could use our special right triangle rules to find the value of x, but we'll use our trig ratios. So from that 30, we've got the adjacent side, which is 18, and then x is your hypotenuse. So adjacent and hypotenuse is going to be cosine. So cosine of theta is adjacent over hypotenuse. Again, plugging in your pieces that you know, we'll say cosine of 30 is equal to 18 over x. Now this is another one kind of like that tangent. We're going to cross multiply. So we're going to have x times the cosine of 30 equals 18. And then we're going to divide by the cosine of 30 on both sides to get x. So x is going to be equal to 18 divided by the cosine of 30, which is going to give us 20.8. All right, looking at the next section, it says finding angle measures. If you know the sine, cosine, or tangent ratio of an angle, you can use the inverse of the ratio, which is the inverse of sine, inverse cosine, inverse tangent, to find the measure of the angle. So in those first 6 examples, what we were looking for was a missing side. And in these, we're going to be looking for a missing angle measure. So the directions tell us to find the missing angle, round to the nearest tenth. So for sine of theta equal to x, to find theta, theta is going to be equal to the inverse of sine. Same thing for cosine. If cosine of theta is equal to x, then the theta is going to be the inverse of cosine. And same thing for tangent. The theta is going to be equal to the inverse of tangent of x. So looking at number 7, we've got theta, and we've got the opposite side, and we've got the adjacent side. So opposite and adjacent would be tangent. So tangent of theta is opposite over adjacent, filling in our parts. Opposite is 8, adjacent is 14. So we're going to use the inverse tangent function. To find theta, it's going to be the inverse of tangent of that 8/14. So going to our calculator, you're going to inverse tangent. If you look right above the tangent button, there's a tangent and a -1. So I'm going to hit second tangent. So there's your inverse. And then we're going to put in our 8/14 inside that parentheses. And we get 29.7 degrees. So that angle measure is 29.7 degrees. Let's jump over to number 9. Number 9, again, looking at theta, identify your parts. The 22 is the hypotenuse because it's across from the right angle. 17 is across from theta, so that's our opposite. Now you're going to identify the trig function that you need. If I'm looking at opposite and hypotenuse, that's going to be sine. So sine theta is opposite over hypotenuse. Again, we're looking for theta. We're looking for that angle measure. We're going to plug in our opposite and our hypotenuse. And then to find theta, it's going to be the inverse of sine of that 17/22. So inverse of sine, so second sine of the 17/22. And we are going to get 50.6 degrees for theta. So those are your examples for finding an angle measure. Now we're going to talk about angle of elevation. For angle of elevation, we've got some word problems. And if you look at the picture that you've got here, there is a, looks like a little boy standing in front of a lighthouse. And the little boy's line of vision creates this horizontal. The height, part of the height of the lighthouse creates your vertical, and it creates that right angle. So you're trying to get that right angle between your line of vision and whatever object you're looking at. And then his line of sight, he's looking up at the top of that lighthouse, and it creates an angle. So the angle with his eye line of sight and the top, or the horizontal and the line of sight, creates that angle of elevation. And in every single one of these word problems here, 11, 12, and 13, we're going to be looking at that angle of elevation. So number 11, let's look at number 11. The angle of elevation from a fishing boat to the top of a lighthouse is 5 degrees. If the top of the lighthouse is 161 feet above sea level, how far is the boat from the lighthouse? So basically, what I do when I work these kinds of problems is I just create that right triangle with the understanding that the eyes are here. This is your line of sight. The hypotenuse is your line of sight. And the horizontal, which is the bottom, is going to be created by you and whatever the distance you are from the object. And then your perpendicular is going to be the height of that object. And in this case, it would be your lighthouse. So let's label our parts. The angle of elevation is 5 degrees, so that goes there. If the top of the lighthouse is 161 feet above sea level, that is your vertical measure. And they're asking how far is the boat from the lighthouse. So that means I'm looking for the horizontal. And now we're going to do just like we did in some of the examples leading up to this. We're going to label our parts as far as opposite, adjacent, and hypotenuse and figure out which trig function. So from theta, we have the opposite. So this is my opposite. And the x is actually going to be your adjacent. So opposite and adjacent is going to be tangent. So tangent of theta equals opposite over adjacent. So let's fill in our parts. The tangent of 5 degrees is equal to opposite is 161 over x. Cross products, we're going to have x times the tangent of 5 is equal to 161, and then divide by the tangent of 5. So x is going to be 161 divided by the tangent of 5. 161 divided by the tangent of 5. 161. I forgot the 1. So that gives me 1,840.2 feet. So the boat is 1,840.2 feet from the base of that lighthouse. Let's do one more. Let's look at number 13. Number 13 says that a 10-foot ramp is used to unload furniture from a truck. If the back of the truck is 3 feet above the ground, find the measure of the angle that the ramp makes with the ground. So again, I'm going to use that same triangle and just label it. Label the parts. So the ramp is used to unload furniture from a truck. So the ramp would be the hypotenuse, a 10-foot ramp. If the back of the truck sits 3 feet above the ground, so 3 feet above the ground is going to indicate a vertical distance. Find the measure of the angle that the ramp makes with the ground. So the bottom is going to be our ground level. I always say that the hardest part about getting these correct is labeling your triangle and then labeling to know which trig function to use. So you've got to make sure you're putting the parts on the right piece of that right triangle. So from theta, I've got opposite, and of course we have the hypotenuse. Opposite and hypotenuse is going to be sine. So sine theta is opposite over hypotenuse. I'm looking for theta. Opposite is 3, and the hypotenuse is 10. So to find theta, we're going to use the inverse of sine and 3/10. So inverse of sine, second sine, and then 3 divided by 10. It gives me 17.5 degrees. Now let's look at angle of depression. So angle of depression is, again, formed from a horizontal and your line of sight looking down. So this is the angle of depression here. Now, what I always tell students is it's really and truly the same triangle. If you think about geometry and parallel lines cut by transversal, your angle of elevation and your angle of depression are really and truly the same angles. They are congruent. The triangles are going to end up being congruent. But I'm going to go ahead and I'm going to draw these as if this was my triangle. This is my person. This is my line of sight. Here's your horizontal and your vertical. So I use that kind of triangle to work these. So here we go. Number 14 says that a fire is spotted from the top of a 125-foot tall fire tower. If the angle of depression to the fire is 19 degrees, how far is the fire from the base of the tower? So again, using this triangle, the fire is spotted from the top of a 125-foot tall fire tower. So I know that this is where I'm looking, but the 125 feet goes here because it's the vertical. Your fire tower is the vertical part. The angle of depression is 19 degrees. That always goes up there at that top. And how far is the fire from the base of the tower? So that means that the horizontal distance is what you're looking for. So these, I think, are a little more complicated to set up to get your parts labeled just because of the wordage. And I feel like the triangle is upside down, but that's your angle of depression. All right, so we've got our opposite, and this is going to be adjacent. So that's going to be tangent of theta is opposite over adjacent. So tangent of 19 is equal to 125 over x. Again, you're going to cross multiply, and x times the tangent of 19 equals 125. So we're going to divide by the tangent of 19. 125 divided by the tangent of 19, and we get 363.0. So let's say about 363. And then I want to jump to number 16, last one. Number 16 says Max is sitting in the stands at the baseball stadium. He catches a foul ball and decides to throw it back to a player standing on first base. If the horizontal distance from Max to the player is 61 feet and the ball travels 76 feet, what is the angle of depression from Max to the player? So again, I'm going to draw this same triangle. Max is sitting in the stands at the baseball stadium. He catches a foul ball and decides to throw it back to the player standing on first base. The horizontal distance is 61, so horizontal. And the ball travels. So the ball is going to travel along your hypotenuse. So this is going to be your 76 feet. And what is the angle of depression? So from theta, I have, of course, 76 is my hypotenuse, and the 61 is going to be the adjacent side. So adjacent and hypotenuse is cosine. So let's set this up. Cosine theta is equal to adjacent over hypotenuse. We're looking for theta. The adjacent is 61 over the 76. So to find theta, we're going to use the inverse of cosine, and that's 61 over 76. So inverse cosine, 61 over 76. And we get 36.6 for theta. So there are your notes for chapter 15, lesson number 2.